And back with number 5. On a college campus of 10,000 students, a single student returned to campus infected with the virus. This is not the coronavirus, so don't freak out. The spread of this disease through the student body is given by that equation, where y is the total number of infected people at time t in days. And so we are asked how many students are infected after 4 days, and how long does this model predict it will take 50% of the student body to become infected. And 50% of the student body would be 5,000 students. So let's go ahead and run that in here. This is an easy one. So there's our deal, and in 4 days is what we're trying to figure out. So our time t is going to be replaced with 4. And so the result of what is y? Y is the total number of students infected. So after 4 days, we end up with just over 52 students infected, so we will call that 53. So in 4 days, time, the number of infected students goes from 1 to 52. Okay, and then we are asked how long will it take for all 5,000 students to be infected. So we are, well, half of the student body, so 5,000 students. We need to put the t back in there. And for our y, we need 5,000. So we get, it will take 9.3 days. That equation, obviously, and you can see in the graph even here in Wolfram, it just takes off like wildfire, like insanely fast, the spread of this disease as more people get infected. And so you can see that it would take 9 days only. That is insane. That it takes in 4 days it only gets up to 52, but that in 9.5 days or so it gets all the way to 5,000. So 5,000 students will be infected in we'll call it 10 days. That is pretty wild. So with that, everyone, I will leave you with that story of a germ, and I'll be back with practice test 2 shortly.